Good afternoon, ladies and gentlemen, presenters, performers, composers, participants of this international symposium. Mikrotöne, microtones, small is beautiful. On behalf of the Internationale Gesellschaft für Eklektische Musik, as well as on behalf of my university, I'm very pleased to welcome you all, coming from many different nations. I counted, I think it's about 10, like USA, Croatia, Slovenia, France, Turkey, Spain, Egypt even, and Germany, Italy, and of course Austria. The title Mikrotöne, as well as the subtitle Small is Beautiful, are strongly connected to Austria in general, as a small country as it is, and in particular to Salzburg and the University Mozarteum, as you will hear in further presentations later on. We have a great variety of presentations. You can hear different instruments, tuning systems. We have 2 concerts, 1 opera, not staged but still in a concert performance. And we have also the possibility to see Mozart autographs, so I hope we will all enjoy and have a nice time together, an interesting time. Just to finish and say welcome to Salzburg. And now, before I would ask Professor Klaus Ager to say welcome to you, I introduce Klaus Ager to you. He was born in Salzburg in 1946. He's a composer and conductor, and he is very strongly connected to our society from the beginning. He was in his early years assistant in the Department of Music Theory, and he is a composer. His oeuvre primarily comprises electroacoustic and computer music, as well as chamber, orchestra and vocal music. Performances all over the world, as you can understand. Klaus Ager has belonged to the teaching staff of the Mozarteum University Salzburg since 1973, and in the academic year 1999 and 1992 he was the deputy rector, and from the academic year 1995 to 2000 he was a rector at the University Mozarteum, and he's a very important person concerning the new music, contemporary music here in Salzburg. He has more or less founded the festival Aspekte, of which he was president and artistic director. The festival devoting its programs primarily to new international chamber and music, as well as performances of opera and ballet. He undertook also with the Ensemble ÖNNM, the Österreichische Ensemble für Neue Musik, several concert tours in Austria and abroad. And he was elected president of the European Conference of New Music Organizers, an association that brings together organizers of new music from 7 European countries. Now, Klaus Ager, thank you.
Welcome to you all. I was not prepared to speak in English, so I just heard that it would be better to speak in English. So please excuse my very bad English and my hesitations from time to time if I don't find the words in English. Welcome to you all. Welcome to the presenters. I'm very glad to have under us Madame Richter Herf, which is a really big pleasure, and to have you here and to hear you talk about old times and the beginnings of the microtonal music in Salzburg. And it's a wonderful day for Salzburg, for the microton, for Salzburg microton tradition, and for the research of microtons in Salzburg, to have you here. and to have this symposium here, where the Symposium of Microtones started 30 years ago, almost at the same place and here. Well, as you know, the building changed here a little bit, but I think we began only 10 meters from here 30 years ago. And it's very nice to re-begin or to continue a tradition of microphone music in Salzburg. The first symposium in 1985 was in fact already the ending point, the final point of a development that began much earlier, that began in 1972 when the Institute for well, I said in German first, Institut für musikalische Grundlagenforschung, which would be something like Institute for Fundamental Musical Research, something like that. Began in 1972 here and was founded by Franz Richter, Herf, and they began to focus in this Institute for musikalische Grundlagenforschung with research work on microtones primarily. And it was interesting that from the beginning, this was not normal in 1972, to focus the research on microtones not so much on the further division of the octaves in quarter tones, in the fifth tones or whatsoever, then to go to a different approach of microtonal music, which then, in the course of the last 30 years or 40 years, turned out to be much more relevant for the future. And that was the idea that we have to have a possibility of notation not for natural phenomena of music and for natural phenomena of acoustics, and that could not be really notated with the 12-tone standard musical notation at the time. Well, there's much of research work made on the notation of microtonal music, so I don't want to bother you with that. But what was the main concern of this research work was on one hand the phenomenon of partial tones, of natural microtonal things that exist effectively naturally, and in a second way, immediately also the evaluation of the aesthetical value, let us say, of intervals and of chords of these phenomena. So I think it was very based on one hand on theory, on the other hand on the practice and on the development of these phenomena of music. And what Richter Herf was very specialized on, he was very interested to find to make a new evaluation of dissonance and of consonance. And so this was probably one of the reasons that this research work became quite soon internationally quite followed, and in the first years, Salzburg was the center of microtonal music, at least in Europe. When I came in 1973 to the studio, I was, as you told, appointed assistant on music theory, and I had the possibility to work on this institute, and I may correct a little thing in my biography here, because I found it already now, not only once. I was not, in 1907, took over the chair of music analysis, not in 97, not 97, but 79 please. So it was a little bit earlier. So that whole thing makes more sense. So my first task in this new institute that was just founded was to build up a professional studio, recording studio, in fact. Because the first research work was made on the monochord as in ancient Greece, so we played sounds on this monochord, and measured the distances and so on. It was like the Pythagoras in the old days. So they began with this, and so I thought it was, and they thought too, it would be good to have a professional recording studio in order to make not only professional recordings but also sound producing. And it was the time of the analog sound production still, and so we had synthesizers, and I invested quite a lot of money in buying professional sound generators, which was not so easy to find at this time, because the problem with the synthesizer, as you may know, is that the stability of the note was quite problematic. So this was my first way here to have a studio at least, and then unfortunately, well, I changed it, and that's one of the reasons why I said that I took in '79 over the other chair. But so my idea of going slowly to digital sound production, or at least to analog sound production with digital control, was not followed very much, and I think that was probably a little lack of would have been interesting to continue in this way. And my second task in the studio was to make really research work, and we had in cooperation with the Institute of Psychology at the university, which worked on a project on Musikwirkung. How would you translate that to English?
Impact of music on
Impact of music from what does music to you when you hear music? It was a big project of the Psychological Institute at the university, and we worked together with them. And the main task here was to see what can you perceive in intervals. And this research work finally came to the idea that 72 notes per octave would be more or less ideal to go as close as possible to the different natural phenomena of microtonal music. Besides the theory that the performance of microtonal music was almost center of the work of the Institute, and it was important to immediately to the results of the work that you had in research found its way also into the composition. My personal work ended in 1980 in the Institute, because of my changing of my career in the Mozarteum. But I accompanied the work of the Institute as being a performer and as being an organizer of festivals. So the Austrian Ensemble for New Music that you mentioned already made lots of concerts with microtonal music all over Europe and even outside of Europe in our tours to South America or to Central America, to Asia and so on. And it was a nice cooperation with the Symposium in the 1980s, and the 80s in fact were aspected, made interesting concerts. So the already mentioned Symposium Microtones won in 85. We made also concerts with works from Richter-Herf, evidently, Ivan Vyshnegradsky and Alois Haber, because Ivan Vyshnegradsky at this time was almost unknown in the world, and I had the chance to know him personally. So I've always found that he was really a very interesting personality in music in general. Or the Microton 3 in 1989, where we had a concert with works of Haber, Jonathan Marie, Julian Carilli and Vyshnegradsky. I have the program here. It was Haber Strike Quartet, String Quartet number 14, quarter tones, Jonathan Marie, tombeau de Julian Carillo, Fabius Brev for triple tone clavier, which is the third tone piano. Ivan Vyshnegradsky, prélude et étude pour le piano de tiers de ton de Julian Carillo. And Julian Carillo Balbuceus for 16th tone piano and chamber orchestra, which was performed in the studio, I remember very well. If you know the 16th tone piano for the Julian Carrillo. You may imagine the whole piano is, I think, 1.5 octave. So, because you have these 16th notes tones. So, it was a very interesting concept. We had to transport the pianos from Mixer, where they are. You probably know that. And, and our tuner of the pianos had the hard work to make the things going. Yeah, welcome to Salzburg, to this symposium. I can gratulate the organizers of this symposium that the tradition of concerts and research work and lectures and so on is continued, and wish you nice lectures, interesting discussions, and nice concerts in the evenings.
For this introduction to our symposium. This is going to be a little history time for the next quarter of an hour, 20 minutes. As you see, we have Franz Herf, who is really our teacher. Many of us sitting here, our mentor, together with his wife, Maria Richter-Taborsky, who's also our teacher for many of us. And so Klaus has already told quite a lot of things. So I go now to my little speech on the presentation here. And I would like to talk a bit about the title I've chosen. It's called Mikrotöne, Microtones. Small is beautiful. The word microtone. We took Mikrotöne from the Symposium, the Gesellschaft für Chinesische Musik made or held. It's four symposia, and the first symposium was in 1985, so we have the 30th anniversary, so that's the main reason why we called this symposium again Mikrotöne. In Memoriam to Franz Herf, and we'll have to mention his colleague Rolf Niedel as well, who they together did a continuous work on research, and so the Niedel was more the researcher and Richter Herf the composer, and so this is one of the most important symposiums, as Klaus already said, the beginning of Microtonality. So 4 symposiums of Mikrotöne, but I also want to mention the Naturton Symposium in Heidelberg, where Johannes Kochi, where is he sitting here somewhere? Yeah, together with Martin Münch, were sort of gave the impasse, and they organized the first Naturton Symposia in 1989 to 1992. And there, the symposia in Heidelberg, the question was about the renaissance of microtonal music, in particular in the United States, France, Germany, and Austria, together with the aspiration for pure and, above all, novel sounds, and the quest for their harmonic interrelations based on newest results in the basic musical research, brought together those musicians, composers, and musicologists at Heidelberg, and Johannes was one of the main organizers. Another important symposium, also thanks to Johannes, most work, was the symposium or a music festival, Oriental Occidental Accord, westlicher Einklang. That was held in 2007 in Salzburg again, and there were 2 very important questions. The one would be: could it be possible to trace back the development of music of Western civilizations in Islamic and Jewish cultures to a common musical basis? And another one was: might be there an all-embracing musical formula but all existing music scales could be reduced to Europe as well as in the Middle East or in Northern Africa. We have a discussion group later, and you can ask Johannes what came out of this. So, I have another important person here, because the subtitle of our symposium is called Small is Beautiful. And the title originates from a collection of essays by the British economist Fritz Schumacher. The title Small is Beautiful originates again from the ideas of Schumacher's teacher, who is Leopold Kohr. And Leopold Kohr was born in Oberndorf, which is near Salzburg. Let me just first go maybe to Fritz Schumacher. This title is Small is Beautiful, a study of economics as if people mattered. It is often used to champion small, appropriate technologies that are believed to empower more people, in contrast with phrases such as bigger is better. He is best known for his critique of Western economies and his proposals for human scale, decentralized and appropriate technologies. First published in 1973, Small is Beautiful brought Schumacher's critiques of Western economies, I think that's very up to date in these days, to a wider audience during the 1973 energy crisis and emergence of globalization. As a young man, Schumacher was a dedicated atheist. I think it's interesting to see that, but his later rejection of materialist, capitalist, agnostic morality was paralleled by a growing fascination with religion. Schumacher wrote his work, a study of economics, Small is Beautiful, in Kohr's house. He was his teacher. And now I switch to Leopold Kohr. There's a quote, which I have to. A small state world would not only solve the problems of social brutality and war, it would solve the problems of oppression and tyranny. It would solve all problems arising from power. Leopold Kohr was born 1909 in Oberndorf by Salzburg. He grew up there, near Salzburg, and it remained his ideal of community. He often commented on the fact that the Christmas carol Silent Night was written and composed as Stille Nacht in his own home village. He earned doctorate degrees in law at the University of Innsbruck, Austria, and political science at the University of Vienna. He also studied economics and political theory at the London School of Economics. In 1937, Kohr became a freelance correspondent during the Spanish Civil War, and he became a close friend of journalists like George Orwell, and shared office with correspondents like Ernest Hemingway and André Malraux. Kohr fled Austria in 1936 after it was annexed by the Nazi Germany and immigrated to the United States. I would like to quote one more important sentence. There seems to be only one cause behind all forms of social misery: bigness. Oversimplified as this may seem, we shall find the idea more easily acceptable if we consider that bigness or oversize is really much more than just a social problem. It appears to be the one and only problem permeating all creation. Whenever something is wrong, something is too big. And if the body of a people becomes diseased with a fever of aggression, brutality, collectivism, or massive idiocracy, it is not because it has fallen victim to bad leadership, or mental derangement. It is because human beings, so charming as individuals or in smaller populations, have been welded into over-concentrated social units. We discovered Leopold Kohr in the 1970s, and I think he's a great teacher to the green movement, and he seems to be the kind of political anarchist. He has quite good ideas about that. He's also a teacher whom I would like to add to my great teachers. Many thanks to my teachers, Franz, Herf, and also to you, Marika, Richter-Taborsky, who taught me singing, and who many of us told us about the microtones, and we started to sing them and to hear them. And as well, special thanks to Agustin Castilla-Avila, who actually is, well, one could almost say he knows all of you, because he was traveling through the world networking and making friends with almost everyone. Every now and then, every second month he comes back from somewhere, all over the place, and tells us about his great connections, and that's a very important reason that you all are here now. Thank you very much, Agustin. And now I would like to invite my teacher and our mum, our musical mum really, Marika, for her presentation. And Marika, just take your time. I have a little. You would want to stay here. I just want to give you this orchid because you told us that's for you. Oh, thank you very much.
Und ich wollte noch sagen, ich weiß nicht, ob Sie das Wort im Englischen kennen, das ist ein Orchideenfach. Something that sort of we said an issue for orchid would be. Orchid is a very, for us in this region, this part of the world, it's an exotic plant and it's very rare. And if researchers in orchideenfächern want to survive, they have all constantly fight for money, for reputation, for everything. And so I hope that this microtonality, as it began as an orchideenfach, may blossom and carry on.
I would like to cordially welcome all participants of the symposium. I am particularly pleased that after 30 years, microtonality is again subject of a symposium, and hence the initiative of Franz Herf will be pursued. My thanks apply first of all to Gertraud Steinkogler-Wurzinger, who has realized the organization of the symposium with great ambition and proficiency. I have 3 topics for my referates, for my short referates. At first about Franz Herf and his way to the ecumenic music, then the foundation of the International Ecumenic Music Society, and the foundation of the first symposium Microtones in Salzburg. Franz Herf was born in Vienna. The ambience, the music, and the culture of this town had an impact on him from the outside. His musicality was reflected real soon. Already as a child he had tried to compose on the piano. At the age of 14 he decided to become a composer. He studied at first at the Viennese Academy of Music and as from 1945 in Salzburg at the Mozarteum Composition and Conducting, where he subsequently also worked as lecturer and professor. Till 1970, he wrote numerous compositions for instruments, singing voice, orchestra, and choir, which were performed with great success. Looking for newer sounds, and in particular for newer harmonies, he was led to the possibility to use microtones, that is, modified pitches of the existing 12-tone system. The first experiments proved that he was right. The novel sounds satisfied him. Since he wanted to put the diversity of potential sounds in a system, he started to analyze them more precisely. He was lucky to find his colleague Rolf Mädel as a collaborator who was not only an excellent musician but also an outstanding mathematician and showed great interest in this research work. After several years of intensive work with sine wave generators and polychords, and with experiments of the hearing ability of microtones, it was definite for them that the optimal solution is the 72 division of the octave, that is the six-fold subdivision of the semitone. They called the practical application of the system ecmelic music. Using these extended capabilities, Richter-Herf wrote numerous compositions for strings, wind instruments, particularly for harps, also for singing voice, choir and orchestra, as well as an opera. He also constructed an electronic fine-step organ with 6 manuals, which is able to exactly implement all microtones of the ecmelic system. In 1974, he was co-founder of the Institute for Basic Musical Research, Institut für musikalische Grundlagenforschung, which after his death has been renamed after him. The ecmelic compositions were very well received by listeners, and by works followed in this system from the younger generation of composers. Now, the second topic is the foundation of the International Ecmelic Music Society. Salzburg commenced to become a center of microtonality. The acquainting and propagation of the ecmelic music required information and exchange of information, publications, lectures, and events with performance of ecmelic compositions. In order to realize these aims, sponsors and subventions were necessary, of course. It was therefore decided to found a society for ecmelic music for the purpose of promoting the microtonal, in particular the ecmelic music. On June 18th, in 1981, the foundation meeting took place. In the period following, it was possible to establish various connections at home and abroad, and to get in contact with composers, qualified musicians, music theorists, and concert managers. The promotion by public government funds as well as by private sponsors made it possible to realize many projects. To pick up some of the most relevant, issuance of 7 vinyl records and CDs, respectively, concert events with orchestra and chamber music, lectures at universities, guest performances abroad, for instance, the Microtonal festivals in the Netherlands. And if nothing else, the cooperation in 4 symposia for microtonality. In the course of years, the number of the members of the International Ecumenic Music Society increased to more than 100. Many young composers and interested music lovers joined us and have contributed to the worldwide propagation of microtonal music. And at last, the foundation of Symposia, of the Symposium Microtones in Salzburg. In the concert activity, the microtonal works conquered broader and broader space. Musicologists were also dealing with these subjects with great interest. The public introductory lectures were attended by a large audience. There were different views on the possibility of the intonation. Apart from enthusiasm, also skepticism could be heard. In order to discuss about these issues and the results being present, Franz Herf and Rolf planned to organize a symposium with lectures, discussions and concerts. They invited well-known musicologists and interested musicians to participate in the first symposium, Microtones, from May the 10th to 12th, 1985, in cooperation with the Mozarteum and the Aspekte Salzburg under Professor Klaus Ager. The confirmations arrived promptly from Austria, Germany, Swiss and the Netherlands. 15 lectures were given on different subjects related to microtonality, many of them with audio and graphical examples. The symposium was open to the public for interested auditors. Thereupon, a long discussion, evaluation, and an exchange of views took place in the ORF studio Salzburg. The symposium was concluded with 2 orchestral concerts and 2 chamber concerts performing microtonal compositions. The success was overwhelming. 3 more symposia followed with the same subject matter, the 3rd and 4th directed by Peter Herf. For each symposium, a comprehensive report, including all lectures, was issued. This was my reports.
So much, Marika, for your history lesson in microtonality in Salzburg. I have now the pleasure to present 2 musicians and one composer, both are composers as far as I know, Sylvie as well. So I start alphabetically. It's Tanja Brüggemann. She's Austrian. She studied piano music pedagogy, jazz, music theory, analysis, and composition as a student of Post Matthäus Johanna, Sigmund Krause, Christoph Pichel, Alexander Müllenbach, Adriana Helsky, and Tristan Murray at Mozarteum University Salzburg. And she did a postgraduate degree for film and audiovisual studies from the film school in cooperation with the Academy of Music in Lodz in Poland. At the moment she lives and works in Linz, as well as in the monastery of St. Florian. She has been a recipient of scholarships of the Austrian government, the Mozarteum University Salzburg, the Anton Bruckner Scholarship, and others. As chairwoman of the ÖKB, the Upper Austrian Composers Society, she founded a networking platform for filmmakers and composers, sound designers within the Crossing Europe Film Festival in 2014. The IGNM, the International Society for Contemporary Music Upper Austria, invited her to curate their concerts in 2015. Her compositions are based on recordings of natural soundscapes and adaptations for acoustic instruments. Her quest is to redefine the real and the artificial in acoustic phenomena. To this end, she consults with researchers and institutions such as the ÖFAI, the Austrian Institute for Artificial Intelligence, the Austrian Academy of Sciences and the Alfred Wegener Institute, as well as the Helmholtz Center for Polar and Marine Research with Lars Kinnemann. Tanja Brüggemann's compositions have been performed at the Musikverein in Vienna, Wien Modern, the Bruckner House in Linz, Kulturforum in Berlin, Musica Contemporanea, Meeting Point Messiaen, the Crossing Europe Film Festival, ORF, and the Salt Festival in Victoria, in Canada. So this is Tanja Brüggemann, and this is her speech.
Wonderful. So thank you very much for inviting me. The reason why I'm here is that I think I started 4 years ago to get really involved into a very special field, which rely on the sounds of the Antarctic Ocean. This special occasion happened that I got to know Lars Kinnemann, who started to build up an observatory in the Antarctic Ocean with hydrophones, and so for 10 years we had an annual delivering of recordings, and it just stopped in December 2014. So what was interesting to me was that there are so many strange sounds that we don't even the researchers could not identify. So there were lots of research done, and I concentrated on two aspects, on two sounds. One sound was the sound of an iceberg, which is scratching on the ocean, and the other one was the sound of a minke whale. Both are sounds that were not identified, and even the minke whales, I think it was in 2014 that the research team from Alfred Wegener Institute in Bremerhaven were able to identify, and so it took them almost, I think, 10 years to really to get the animal together with the sound. Let's say it like this. to start with this interest on a very special, I would say, tonality. I found out that there was a certain acoustic, let's say, microtonality on the minke whales. They had a very special, some kind of glissandi and whatever, so that you could see, you could hear. When you listen to the sounds, they are open source, so you can have a look at Palaoa. You can see it here. It's called Palaoa, the Annual Acoustic Observatory in the Antarctic Ocean. You can see that this is the ice shelf, and here in the very back there is this little arrow where you can see this is the Palaoa station which was built. So I started to concentrate on the minke whales. To get all those sounds lasting for almost a decade, the team of Wegener Institute drilled 4 hydrophones into the Antarctic ice shelf. So they built an array to get also the to identify certain creatures, certain individuals in the Antarctic Ocean, because very, very little is known about the species in the Antarctic Ocean and the population. So 2 hydrophones still maintained. And I would like to show you the beginning of my composition, Ritus. I was listening to those sounds of the minke whales, and I started to, I don't know if you know this software, it's called Audacity. I started to look at the sound of those minke whales, and even when I listened to the sound, I could find out that it's not just in a perfect system as the researchers thought, because what they did was they just counted the numbers of the minke whales' vocalizations. You will hear that later what I mean by that. But there was a kind of a very certain communication within sequences. It was even like a strophe where the individuals would get to a peak and then coming to an ending, which is very interesting, and this is what I started to work on. So I started with this 19-tone scale between A and E flat. This depends on another situation which happened, because the blue whales they are communicating within a tritone. So there's another connection to another animal. What you hear now is the sound of a minke whale. It's also called bioduck. You could hear it all over the world. It's there is the southern Antarctic minke whale and also the northern Arctic minke whale, and it's a very special sound. You can see that it has very certain patterns, time patterns, and it's repeating. And when you listen to it like that, then you think it's just like a quacking, like a duck. But when you look closer to the sounds, then you can see all those structures inside of this sound. now is another minke whale from quite far away. It sounds even deeper, and it can sound even like a bass drum. I will show you the next page. So this is what I was also working on. You could have here lots of information. That's a spectrogram, a 5-minute spectrogram of different individuals. You have adults, you have the blue whale. On the right side, I don't know if you can see, there is on this here, there, this is the blue whale area. Here you will see the minke whales, so you can see the very ordinary, in order, the sequences. Here we have the rattles. Yeah, like which is also very nice. We have another animal which sounds like a laser, Star Wars laser swerve. So it's really funny. And what is so special about the minke whale is that they are just appearing in Antarctic winter. So they are vocalizing in the Antarctic winter, and this is even for researchers very interesting now that they have this observatory to really get into the counting of those animals. So what is also very good, what you can see very well, is that that we have those different individuals of minke whales. And you get kind of phasing. And why I'm telling you this is the reason that I used kind of a delay for the flute. Sylvie Lacroix. It took a really long time to find a possibility to move her voice into very deep ranges. And to get this very special sound of the minke whale. So Vigorous is also, as I told you, it depends on a 19 scale, 19 microtonal scale between A and E flat. And what I wanted to create was a kind of a choir of minke whales. And what to me was very important was to get like a physical feeling of two tones together. So let's say the interference between two tones. And also we were working very close together, Sylvie and I, to find a possibility to get this, those possible, to make it possible. So now I'd like to come to Ager, which is the second piece. You will be able to listen to it now. Ager to me was a very special moment, because in Ager you can find all this kind of silence of the Antarctic area, and I'm very happy that I'm here now, because I feel very, let's say, silent also, and to get the space for the sounds to develop. Because what is special in the Antarctic Ocean is that all the sound that you have is sometimes doubled, so it will keep very strong, it will be very loud, and so there is also a big issue on noise in the Arctic Ocean and in the ocean in general. So what happened was that, maybe you're interested in that, there was a conference dealing with, it was called the Silent Ocean Project. Researchers and also, I think it was the UNESCO, tried to think about the possibility to have no ships, no oil stations, no drilling, nothing in the ocean, so that you can really hear the animals and the individuals, and also, of course, architectonic and other sounds. So the whole oceans would be free of commercial noise. And this is very interesting because if this would happen for a day, we would need 24 hours because it takes 12 days until the whole noise would calm down, and then another 12 hours so that you could see what is really the sound of the ocean. And it is said that the whole economy of the world would crash. So, of course, they didn't do it. And I think it's a nice idea to start thinking about this pollution of the oceans. And it is assumed that this is also the reason why we have all those problems with disorientated animals and so on and so on. So the second piece that I wrote, was this. You can see this iceberg. Also, you can see the little penguins there. This iceberg was scrubbing on the seabed, and researchers could not identify what it is for a long time. And they checked all the activities from other ships and whatever, but they couldn't find it out. And then finally, because they are internationally connected, they could find it out. And so this is actually how it looks like when an iceberg scrubs the seabed. What you will also hear is the beginning. You hear the weather, some ice falling down into the ocean, breaking, iceberg breaking, and then after that. What we took for the recording session were 7 microphones. The reason was that I wanted to have the specialization of the sound of the Antarctic Ocean to allow different perceptions of sound characteristics, and also the acoustic reverberation. So today we are going to have a performance. We will play OR1, and we will have 3 microphones, a lavalier for inside the flute, and 2 other microphones. And Sylvie, would you please prepare for your...
For Sylvie Lacroix, she is from Lyon. She lives in Vienna as a freelance flautist, performing principally as a soloist and chamber musician. She's also an accomplished traverse flute player as well, and playing all over the world with Hammerchor as well as on the Salzburg Festival at Mozarteum. And she's a composer as far as I know. Okay, welcome to you.
Maybe I can say a little bit about this recording. We have 3 different kinds of very, very gentle and subtle sounds, because in the Antarctic winter you can hear only like kind of a wind, because the hydrophones are very sensitive. And so Sylvie tried to create an artificial, let's say, mirror of the Antarctic Ocean. I'm very interested in creating kind of a database for musicians, because we were thinking of, I was thinking of notating the sounds, and I found out that the best way would be to have kind of a sound library and to record the sounds and also show the microphones to get the very special creation of the sound. So this is the lavalier now. And because we have a very special microphone section of turn on and off, I have to go with that.
Thank you very much for this interesting presentation and for the performance as well. We have also a very important person here, which is Jan, our technician. Whoever has anything question. Discussions quite soon at the coffee break with everybody upstairs. Now, one more presentation by Kai Bachmann, where he is. Kai Bachmann is a colleague of ours. He comes from, when he was born in Ludwigshafen in Germany. He studied composition at the Mozarteum University Salzburg and musicology and Spanish at the University of in Salzburg. He did a doctorate in musicology in 1999. Furthermore, he studied at the Universidad Autónoma de Madrid and did a doctorate in music. He was assistant at the Richter-Taborsky Institute for Investigation into the Fundamentals of Music and the Scientific Network, Math and Music. Currently, is a university assistant in advanced listening and supervision of academic projects at the University of Salzburg. And now we're going to learn a bit how we listen to Feinstufenintonation, we call it. Okay.
criteria Feinstufenintonation, which is held here at the Mozarteum. It's a 2-semester course which combines some theoretical concepts of acoustic and music theory and some listening exercises. And just to give a little idea what is spoken about in this course, it's divided into the first 12 units, the first semester. We deal, as I told, with some central concepts, and the second part, the second 12 units, then make a journey across music history, dealing with the question of tuning systems, the development of tuning system, the transition more or less from Pythagorean system at the start, at the beginning, to the equal tempo system which we use nowadays. And there we are checking about 50, 60 different ideas or suggestions how the tuning system could be, what could be the best for the musical practice. And besides, there are some listening exercises included, dealing with quarter tones, with 6 of tones, or small steps of tones. We later have a little bit of these exercises here also. And I told the theoretical background in the first part, speaking among other things with the cent calculation, how to calculate and denominate intervals in cent, and dealing with it a simple way of 3 steps of giving exact size of the interval in cent. Then the tone system and the just intonation as the more or less opposite way of seeing this tone systems. Then speaking also about tone relationships, which is also one of the essential concepts of the course. Concepts of sonance and distance, 2 components of an interval. The interval itself is also dealt with, and of course the partial series of tones, which is one essential concept. For all the other ideas have to do somehow with that. Concept of modulation, consonants, one of these difficult to understand concepts. What the idea of harmony has been in those degrees. And finally, ideas or ways for tuning some shorts. In this concept, I will enter a little bit more extensive in a few minutes then. And as already told, the second 12 units of the course starts more or less historically in the end of the 14th century, when the Pythagorean system was still in use, but already some little changes were suggested. And after discovering that beside the fifth or the major third could be with its relationship also a way of constructing tone systems, the possibilities grow and grow further, than the concept of temperature came to also the thing got really complex until more or less end of the 18th century. All this again came together the equal temperament as the only remaining way of constructing tone systems. So, a little bit, I don't know how many time we still have for extensive with that. Okay. Tuning shorts with a question: is there one general way which can be used for every type of chords we can imagine. So this is some guideline which can be used for every chord we can think about. We can say yes, but. Yes, in the form that if we try to find our chord a common partial tone series where all the tones could fit together, that we have one common basis tone, then the thing is very easy. Sometimes it's a bit tricky to find the best way how to adapt it. And then, if we have found our common tone series, then we tune our tones in the order of the appearance of the tone, but not the ordinary number itself, but it's the prime number which is behind. We can reduce most of the tones to this common prime number. See some examples how this works soon. Of course, no rule without exception. If you have in our chord some very stable interval in octave or every fifth, but between higher on the numbers of the partial tone series, then we can, of course, also start with this strong interval first. So it's not really a perfect, universally valid way, but a way which could be function in nearly all tones we have. So to start with a more simple example, one chord which we really don't need to analyze. Just by seeing this, our stomach will also give us the same way of starting here. The two tones in the lower part, C and G, would be the fundament we start with, and the rest comes later. If we apply our idea with a common partial tone series, then we would have, if it appears, the common basis tone C. So we have the second, the third, the seventh, and the 10th partial tone. We can reduce this, the number 10, to the prime number 5. Or else we are already prime numbers. Then we see 2 and 3, the lower, the smallest prime numbers. So we start with then the 5, the E would be the next step, the complex, the major chord, and the B is the last tone which comes together. But not every time the thing looks as easy. For example, the next, which a simple side is not a very complex chord. It's also a triad, a D minor with a seventh. But here, with a special inversion, we will extend a little button, of course, which would be the best common tone. If you think functionally, it's a D, but it's really the best way to take all this tones together to a common basis tone. Or is a better solution there to be seen. Not D, but the best thing is to think this in E flat. So we have so the basis tone B flat, partial tone 6, 10, 15, and 18, which can be reduced to the prime numbers 3, 5, 5, and again 3. This tells us that this exterior fifth in the lower and the highest note should be the interval we should start with. Then take the A to complete the F major chord, and as last note then the D. This is contrary to the functional way of seeing the chord, where D is a basis tone, functionally speaking. Of course, also would be possible to start with the inner fifths. It's maybe a little bit more difficult, but not impossible. What again shows us there's not one way which we can make the things. We have many times different ways. A little bit faster, a little bit surer, but not only one way. Speed up a little bit. What happens if our throat is gone? It is not so easy, comprehensive, it cannot be constructed in trials. This here, the throat, which could be reduced to D as a basis tone or not. If we think D is our basis, then we have the partial tones 5, 8, 13, and 17, and that gives us the idea to start in the lower 6. The two other tones are very high prime numbers, so it doesn't matter if to continue with the B or the E flat. So this possibility of seeing the G as basis tone starting with the lower tones. But we have also a different way of analyzing this. If you think this F sharp or this F sharp, but we translate it to the G, F sharp to a G flat, then we get a completely different way of thinking this short. An E flat minor short is there now, which can be seen. Common basis tone C flat, and suddenly we get 3 very small numbers, 12, 30 and 40, reduced to 3 and 5, and 1 high prime number for D as the 19th. That now means we start not with the lower 6 as before, but with E flat and E flat. That's a completely different way now. D, which the other way of thinking it was the starting point, is now the last tone to be tuned. And one more idea to this. What happens if our throat is so complex that we don't find one common basis tone? What can we do? Here the best way would be to separate this into some smaller parts which for itself can be easily understood. For example, here we could pull out an E flat major tone with 2 highest tones and the E flat on the basis, or the E from the lowest tone and the F sharp together with either C sharp as 2 fifths, or with a B minor would also be possible. We can divide this into 3 portions, which for itself are easily possible to tune, which would be as told the B flat, with basis B, having already the B tuned from before, we can also help us to perform the second part in F sharp major, and the rest of the tones are B flat major chord in the second inversion. And so we have as largest numbers here the 5, or the rest can be reduced. This now is quite more easy than the first moment, which looks to be very complex. So far, this little introduction to tuning of shorts. We still have time. A little bit from the listening part. One exercise dealing with tone steps. 2 tones in the distance, which are almost equally, or maybe even exactly equally or the second tone can be a little bit higher or a little bit lower. Sometimes the differences are 10 cents, sometimes only 5 cents. The question is, can we get to the correct movement? Can we guess what happens? For the home parts we can listen and hope it functions. Let's see. Some seem to be very easy to distinguish, some not so easy. Should we once repeat, or just once and then try to guess what we had? There's a more easy series still. Anyone has an idea what we had? Step directions? Up, down, up, down again. Okay, now a little bit more difficult. Second series. Suggestions?
I prefer the last.
Down, this, up, down, down. Should have one more of them. Yeah.
Well, the first is done, I guess.
More complex, like this. Where's the nose? So that's way how these exercises are functioning. They're also then sometimes with smaller steps, only 5 cents, but usually this also is detected without greater problems. Then just jump a little bit forward. One example of tuning systems, one of all from this summer semester. As we don't have so much time, we jump through. It's a name really not so well known. Charles Williams is not, no matter if it's not so well known. This idea is quite interesting, but not very helpful with musical practice. And we have the Germanus, published in 1743, this tuning system idea. We have the fortune that he has described very well how he came to this tone system. He uses monochrome string, 48 units long. Half of them is taken into account, and then he tells us that this part is divided in 4 equal size sections. And then the tones B, F, and A flat are marked together. Then, next step, between C and D, exactly in the middle, at the position 45, E flat is put there. Then, the 2 middle sections are divided into 3 equal sized portions for E flat, E, F sharp, and G. And the last section is divided into 4 equal distant parts, which means every section is 1.5 large. And then Rins makes fundamental error, because then he calculates not with 28.5, 25.5, but only with the musical numbers, which leads to completely mistuned A and B, and the consequence to a very strange tone system result. Just to show one thing, I think E has the proportion 8:7 and the long A 12:7, so 2 portions, where the relationship of sevens appears as the only tuning system known where this happens, and it is a good or not good idea when we would have an opportunity to listen to it, then we know it's not so good idea. That's why the Rins system was also not really used in the musical praxis. Yeah. Okay. We finish here. That is the point.
Discussion here.
Okay. Thank you for your patience.
In 2000, he was nominated for the NPS Culture Prize on Television for his quarter-tone composition Continental, and reached the final. In 2001-02, he was offered a stipend at the Internationales Kunstwerk Concordia of Bachmann, and so forth and so forth. As a saxophone player, he performed with several orchestras and ensembles since 1990, including the Radio Philharmonic Orchestra Holland, the Schleswig-Holstein Festival, and so on. Many, many performances all over the world. And as a composer and saxophonist, we welcome Germanus here in Salzburg.
Yes, start with standing. She already told you that that's the main thing why I'm here. I'm the director of the Herf Foundation and also artistic director. The Herf Foundation is based in Amsterdam, Holland. We have a beautiful organ which is called the Fokker organ, and this is a 31-tone organ. I was thinking maybe to listen to this after I introduce a little bit more about the foundation. We do a lot of concerts, we have a lot of activities, and the main instrument is of course the 31-tone organ. We also have a 96-tone piano, which is the 1/16 piano already mentioned here. We call it the Carvillo piano, in the same line as the Fokker organ. Now I want to start with a little of the Fokker organ, very small piece of the 50s by Hans Box. very short piece, Larghetto of Hans Cox. I think it was 1957. I have to talk really short, so it will be short is beautiful today. I try to give some music examples too, but it takes too much time to fade in, fade out, so I have to be brutal a lot of times. Just come in and come out, so hope you forgive me. Going to the early history, and of course many of you know already many things about the early history of microtonality, but hopefully some not. First I go to Christian Huygens. He was a very famous physician in Holland. He invented a lot of things and he described for the first time the rings around Saturnus. He discovered Titan, but he also discovered the 31-tone music, the circle of fifths, 31-tone fifths. He did this actually because he wasn't happy with the new tendency of using 12 tones equally tempered. He thought that the third was so out of tune that this could not be happening. But of course, the reason of having this new system was to be able to modulate to all the keys, and that wasn't possible with the Meantone system. So he was searching for a system which could modulate, ongoing actually, but still have this pure third in it. So, and he wrote the Nouveau Cycle Harmonique in French, and in this he described actually his whole idea. He also described an instrument to play this that was actually not so well thought about, because it was all the snares should be going like this and the keys should go like this, and you could not play really fast on it if you wanted, or go in a fast way to another key. So this was never built, of course, and nobody heard after it anymore. So that was actually the start of 31-tone music in Holland, but it ended there. He wrote it in 1691, not knowing that already in 1551 Nicola Vicentino invented the same thing, the 31-tone system in Rome. He wrote it in 1555 in excuse me for my bad Italian, L'antica musica ridotta alla moderna pratica. And it was actually an article about using this new way of tuning and dividing the octave. And there was a kind of discussion with another musician, theorist, Vincente Lusitano, about the ancient Greek genera. And he actually lost the discussion, but he wanted to prove them wrong, and he wrote his first madrigals and published them also in 1955. Few of them are still there, it's only 4. 2 are complete, 2 are half. I want you to listen for a moment to his music, played by our own ensemble Scala, 4 people of it. Yes. Musica Caput, 1555. 31 is going to change to all the other notes. So that's interesting. It was in bar 31. Flute, the normal tuned clarinet, the viola, and in the bass you heard the proper organ, 31 tone organ, which actually gives the basis of the Meantone tuning. So, a little bit about the theory behind the 31 tone music. A lot of you, of course, know that too, but again, not for everybody maybe. What is mean tone? In mean tone, all the same tones are not on the same distance from each other, so it's uneven actually. It's 2/5, 3/5, 3/5, 2/5, like that. And that makes that there is a difference between, for instance, the D sharp and the E flat. So these are different notes in our current system. They're the same, and that's because the third is now really out of tune. In the current system, you have this. This is the fifth harmonic, of course. And when we do a few fifths, on each other, so like this, we have the same E, but of course not. This is slightly higher when you have pure fifths on each other. And we have the fifth harmonic, and the difference is this. This is the syntonic comma, which is the problem in all music. But to keep this one, you need, for instance, the mean tone system. The fifths are a little more flat actually than the current system, but the thirds are so much better that that's really a big difference. I think the fifth is like this, if I'm correct. This is 7 cents flat, and with mean tone it's mostly something like this flat. So there's a difference. The 31 tone system is more like this flat. So there's a little like 3 cents difference between current system and the 31 tone system. So, all these little steps, the 31 tone steps, we call them diases. You can count what a diase is. I will say this for a moment. Not much space left. Did you have this, Jan? Did you have this thing somewhere, or just a paper? Yeah, I have a paper.
Gertraud?
Yeah.
This is special.
Perfect. So, if you have 12 fifths, yeah, this can already. If you have 12 fifths, which are 700 cents, 1212 multiplied by 700 is same as 7 octaves. Is 0. 12 fifths, 7 octaves. Sorry. Minus. So, but actually, the fifth is a little lower, which is this. So, this is the real fifth, the pure fifth. And in the meantone, the fifth is standard meantone. Is actually flat. So this is pure fifth. This is the meantone fifth flat. 700 minus this. So now we want to know what the diase is. We do 12 times. It was actually the pure fifth minus the 5.377. What is the meantone fifth too low? This will be this. If you get that off. So 12 times this minus 7 times 1200 is this is a 41.050. If we do the 31 tone system, we have 1200, and we divide it in 31, and that will be 38. Dot, 71. So the difference is something like 3 cents, a little less than 3 cents. So this is a diase in standard meantone. This is a diase in 31 tone equal tempered system. So it's really close, but with this system you can modulate to all the keys, and with this not. That's actually the thing. So, advantages of the 31-tone music. One is you can play a pure harmonic seventh on it. Really pure, it's just 1 cent off, that's nobody will hear that. So, and that's great because we lost that. It's actually a consonant tone, and we lost this in the current music system, the tuning system. We can also play an 11th harmonic, of course, 13. They're a little bit more off, but when you use them in chords, it will still work as a harmonic, and that's great. So we have a better third. In 31-tone music, it's system. It's something like 0.7 cents. That's almost nothing. In standard Meantone, it's 0, so it's almost the same. Pure thirds, better sevenths, and the possibility to 11 and 13 and so on. That's actually an advantage. And what is an advantage? That it's a lot of fun with 31. And I will ask Stefan to play something. And he has a, let's say, 17 out of 31 guitar. And he will play a chord with a 7th harmonic. That's beautiful. Can you play the 7th harmonic like a normal minor 7th? 1 ES higher. And now, yeah.
You will hear microphone.
Yeah. That's the difference. Okay, we can also play an 11th on it. Maybe you have the 11th. A chord with the 11th in it. Yes, and some chord progressions with the 7th harmonic.
Oh, yeah.
Number 3. Very good. And there are some others. Some other chord progression.
Oh yeah. Steps are very small. So.
Notation. A few ways to notate. Standard meantone notation is this. Can you read this? This is a But we also have the 31 tone notation, and then we use also double with half flat. So this is, if you make a more consonant kind of music, it's more logical to use this notation. This is normal actually. And we can go back or just do it like this. Sorry, this is only one between, sorry. Like this. This is a typical 31 tone notation. It's actually enharmonic with the C sharp. So this note is the same. But when you are writing something down, so this is actually, we'll write it the other way, so descending. Then it will be best to write it like this. When you go up, you can write it like this. It's more in a more standard music theory way. If you write in a more abstract way, you don't need this at all, because all the notes are in another or in a different way related. So then you just use the tertinic notation. Three ways to notate 31 tone music. This is 1, 2, and this is 3. I will not finish my thing in time, but yes, tell me.
There are too many steps for one octave with 31 steps.
Well, every whole note is 5 steps.
5 steps.
5
Yeah.
or 1?
Yes.
5
tones.
6 tones. 5 tones.
It's a fifth tone. I will tell you why. 31 tone is a fifth tone system, but you all will think, why not 30 then? Now you have 6 whole notes in an octave. Da dee da da dee da dee da dee da dee da, like that. You divide them in 5 and you have a 31 tone system. But we have 31. And that's because the theorists in that time, they thought about the white keys, just the 7 white keys. So they divided each whole step in 5 and each half step in 3. So we have 5 whole steps on the white keys and 2 half semitones, so half steps. Whole notes, 5 times 5 little steps, 5 whole notes, so divide them in 5. 5 times 5 is 25. With 2 half steps, divide them in 3. 2 times 3 is 6. 25 plus 6 is 31. That's the thing. And when you have something like a keyboard, draw it You have another Meantone system which could modulate in a way, 90-tone system. They add between each white key one extra key. So you would have here, this is 12, and you have 7 extra, and then you have 19. And with the 31-tone system, you add 3 between all notes, and 2 between all half notes. And you have 31-tone keys. You already saw the keyboard of the Fokker organ, and there you can see that. It's really high, but there is C, D, E, F, G, A, B, C. Between them, we have a C sharp and a G flat.
Color, otherwise you don't understand what you say.
So,
you have to tell the color, because if you say just pointing there or there, then it's
sorry. I just pointed to the white keys now.
Okay.
I'm going to point to the black keys. This is the black key. This is the C sharp. It's just next to the C. The one higher is also a black key, so you have 2. That one is the D flat. This is the D sharp, and that is the A flat. And A flat is higher. From the bel canto singing, you take, for instance, a D sharp very high as a leading note, and an E flat low, down. But actually, the E flat is high, it's coming from E, a little lower, and the D sharp is low, it's coming from the E a little higher. So, and all the other notes between, this was the C, this one is actually the C. That's in Dutch actually the C half sharp, let's say. So the blue keys are what's between, what's left actually. That's how it's done. So, I'm going to tell you a little bit about the history of the 31-tone music. 1940, there was a bundle of all the scientific work of Havens, and this one, the 20th, was only his music theoretical readings, articles. And he was writing about 31-tone music, I already said it, Nouveau Cycle Harmonique. In 1931, Fokker read this book, and that was the first time that he really was touched. And in 1942, that was really a turning point in his life. From that time, he only was focused on music, or more focused on music, because actually he was a physician, Adriaan Fokker. It's also the name in the Havens Fokker Foundation, of course, and Fokker Organ. He was a scientist, he was a lecturer at the University of Leiden. He was a physician, and he invented a lot of things in the physics. But from 1942, he was mainly focused on 31-tone music. 1946, he presented the 31-tone music to a wider audience. And in 1950, he constructed the 31-tone organ. Not himself, of course. He invented the whole key mapping. And it was built by Pelsen van Leeuwen in a town called Den Bosch in Holland. In 1951, it was placed in the Taborsky in Haarlem. Haarlem is the city next to Amsterdam. There's a museum called Taborsky Museum, it's actually the oldest museum of in the Netherlands. And he was a curator there, so he had possibilities to place it there in the auditorium. Lots of concerts happened there, and it was really the best place at that time to have the instrument. In 1960 he initiates the Stiftung Nauluisterendheid Foundation. Nauluisterendheid is something like what Kai was talking about, the Stuben hören, was war es? Was? Feinstufenintonation, yeah. Nauluisterendheid is something like Feinhörenheit. So, and this was actually the what now the Herf Foundation is. It was the foundation at that time. In the 60s and 70s he gave many presentations all over the world about 31-tone music. In 1972 he died after 31 years. That's beautiful also, working with 31-tone music. So let's listen to a few pieces of composers who composed works. Okay, I will put it up for a moment. Who composed works especially for him. He inspired a lot of people, musicians, composers, music theorists, and this is one of them. Henk Badings, who wrote many works for the 31-tone organ, but also for a violin duo, Jean Vos and Paul Lemkes, who played 31-tone music on their violins all over the world. He's a main Dutch composer. They had a real fight about using all kinds of clusters in his music, and it was really written in all the national papers. They never understood each other. This piece was from 1962. Another famous composer, Ivan Wisniewski, wrote for the 31-tone organ. That was a great honor. We played this piece many times. Although, of course, we cannot always do the same thing for our audience. You will hear a little part of it. I scroll a little bit.
Could you please repeat the name of the composers?
First one.
No, the last one.
The last one. Ivan Wisniewski.
Okay. And before?
Oh, sorry.
Before? The one
Before. Henk Badings.
And then?
Then Peter Schat.
This one.
Yeah. Peter Schat.
Peter Schat.
S-C-H-A-T.
Nie schatten ohne N.
Okay. Thank you very much.
Yeah. I found letters in the archive that Fokker was writing with Memoriam. He was writing with Edgar Verreese and many other big names. So it was really incredible the connections he had. And it was also a great honor that Pierre Boulez even came to Haarlem to play on the instrument, to try it out. He promised to write something. I'm still thinking of sending him a letter that he has to still do that, but I think he's too old now. But he was there in 1965. So, as I said, in 1972 he died. Afterwards there were many other concerts organized also by the main organ player of the 31-ton organ, Anton de Beer. Later we got another player, Joost van Goosen. And in the 80s, in the 80s, the name was changed to the Huigens Fokker Foundation. So it was not now Luisterendheid Foundation anymore, but it was this. And the task or the purpose was also to be a center for microtonal music, for all kinds of microtonal music, but the main focus was still on 31-tone music. In 1999, the Fokker organ had to be removed from the Tylers Museum. That was really a dramatic decision by the museum, and it was locked up for 10 years almost. It had to be removed because they needed a it had to be removed because there should be a invalid elevator on that spot, which is of course understandable. That was very pity for the foundation, of course. Nothing happened almost in these years. There were some other concerts without the Fokker organ, but actually nothing happened. I became director in 2007, and I started with finding money to renovate this beautiful organ. I did for big amount. We could renovate this, but also modernize it, and now it's completely with MIDI technique. So the great thing is you can hang on a laptop, do whatever you want. Young composers now work with all graphic kind of Max patches and I don't know what, and they just play on the organ, they do play and something is coming out. I will give an example from that. Sorry for this, I don't know. This is just the sound of the what's the English actually? Clapper. A little louder, Jan. This is only the organ. It sounds more like electronic music. It's just the organ. Love to let you hear the whole piece because it's great, but there's no time. Sorry.
And the composer?
Hmm?
And the composer?
Danny de Graan, sorry. Danny de Graan. Here another example of Hector Bravo Benard tapestry. Another example, Rosalie Hirsch, great spectacle. So that explains it. Yes, I want to do many more things, but I'm going to quit now.
I'm sorry, Sander. Stephanie, we play also.
Yes.
Because it's been 50 minutes already for you.
Yes,
I'm
going
really sorry
to.
because I'm personally very interested in this lecture. But the guy will come in 10 minutes. Maybe we can hold 5 minutes. But
you take your guitar and I will put a little of an ensemble. He's playing Ensemble Scala. It's a ensemble for microphone music. I initiated to have a digital vocal organ outside the small hall of the muziekgebouw where the organ is placed. Oh, sorry.
light speed, or to play at light speed, but that will not be possible. I'm Stefan Gerritsen, I'm from Holland, from Amsterdam. I play a lot of different styles of music, and since 6 years I also play the 31-tone guitar. In fact, I play 3 different 31-tone guitars. One is an acoustic guitar with all the 31 tones in it. Then we have an electric guitar. And the guitar I brought today, I could only bring one guitar by playing, so that's the one I play more solo, concert hall. That's the Herf guitar, and that is a guitar with a selection of the 31 tone notes. So all the notes on the fretboard are tuned according to the 31 tone system, but the more microtonal notes, like A half flat or C double sharp, they are not existing on this guitar. What I do have is most of the enharmonic notes. So I have a different fret for a G sharp and an A flat. Like this is a G sharp and this is an A flat. Something wrong with the guitar here. I was already tuning to the lute tuning, and now the whole system doesn't work. So this is a G sharp, and this is A flat, and I have the same for the C sharp and the D flat. The E sharp and the B sharp are not available on guitar, because the aim of this guitar is that to play classical Western music, so Malaysian music, rock music, and the goal of the maker was to make a guitar that you can play with these pure thirds, all music. So I will show you some examples of music which I think fits very well on the instrument. Music from Spain, from the Renaissance period, to differentias from Luis de Narvaez, and then the Fantasia on Marca, the Ludovico Mudara. Now I will make the history of the composers a bit short then. Narvaez was a composer who worked at the court of Philip II, and he played, like Mudara, the vihuela, which is an old Spanish guitar, very small instrument, double strings, quite a limited range, and I think Narvaez is a fantastic composer. It's unbelievable that he could write for such tiny instruments real polyphonic music in the style of Suske Oker. What I already told you, I had to tune the G string back to the F sharp to be able to play the fingerings of the lute or duetta. So, 2 differentias and then directly I play the Fantasia. Now I have to tell you about the Fantasia from Mudara. Mudara wrote in the score something very peculiar. He said, you will encounter some out of tune wrong notes, but well, if you play them right, then they don't sound that bad. No. Just wanted to check time. What I would like to tell, I started about 6 years ago with 30-little tone guitar. It all started because Sandra told me that there was an existing 30-little tone guitar also in the museum of the Museum in Haarlem, and he asked me to take a look at it. So I saw the instrument, but it was in very poor condition, and in fact it was also a very strange instrument. It was more like a jazz guitar and more for like plucking chords. Maybe you can see it. Yeah.
This is the one you brought to Stuttgart?
No.
That was with chorus. No?
This guitar is history, in fact.
Really old. I don't know how old.
I don't know if there was any guitar player who played on it. It's nothing documented.
Oh, interesting.
So we in fact said, no, this guitar will not work. It's better to make another one. So I went to my guitar maker, Otto Valwinkel. He gave us a nice study model guitar, and then we asked a guy, Sylvie Lacroix, to make the fretboard. And Sylvie Lacroix is, we owe a lot of credits to him. He is half Canadian, half Dutch, and he's an amateur guitarist and a mathematician. And he's, since the 70s, he's making and inventing all kinds of fretboards for microtonal plucked instruments, mainly guitars, but also violas, etc.
That was the one, right?
That's the one, yeah,
okay.
Exactly.
I remember.
Yeah. So he made the calculations of the frets, but I'll tell you about the course a little bit later. He went to Sebastian Nunez, who made from mandolin frets. He made the guitar, so that it's much better in fact than this guitar because the frets are so thick. So now it's more easy to place the fingers, or a little bit easier. Well, you can imagine that playing a guitar with so many frets is quite complicated, and that's might be the reason that it's not so popular. It's not a big hit, it's not a guitar. But one thing, what happens is that you add more frets and you get less sound. Yeah, because there's not enough space, you have to press really hard to make the sound, so you don't have not a lot of sustain of the note. So one of the solutions for that is to play the electric guitar, which I do a lot now in the ensemble. I'm not sure if you have a picture.
No, sorry.
No? Okay. The other big problem as a guitarist is how to find the notes. If you jump from one position to the other, you don't know what note you play. Like if you're with a student, you say, well, you have to go to the 7th fret, and then you see the student counting 1 to 7. That's not really a solution with 31 tone notes, frets in an octave. So if this is the guitar, and then on this guitar or on that guitar, this is on the 12th fret, the 31st fret. So if I play a chord and I don't have to think on this guitar that much, but on the other guitar, it makes it very difficult. Well, Simon Terpstra made a beautiful solution to that. He invented a color system. So he uses 4 colors, black, white, light grey and dark grey. Maybe it's better to show you the guitar again.
Yeah.
And that makes it much easier for the orientation of the guitar. Of course, it's not a piano, so but there's still some general rule you can apply. The white and the light grey frets most of the times are the more common notes, like a C sharp, D flat, and the more microtonal notes are normally the black frets and the dark grey. But of course, it doesn't apply to all strings in all positions. It's impossible. But it's a big help. Then the electric guitar has also a color system, but with different colors. Makes it a little bit more complicated. It looks very fine, I must say. It's very spacey with light blue, orange, and yellow. So it looks good in the public, but I prefer this system. I return back to this guitar. I'm not sure how much time I have. Can I play?
Actually, the guy is already there. I will try to hold her, but please continue.
Okay, yeah.
Sorry, one question.
Yeah.
This system of frets works only for equal tempo. 31 tone, but equal tempo.
Yeah, it's all equal tempo.
Only for equal.
Yeah.
Thanks.
I wanted to play in fact 2 pieces, but maybe it's better to play something contemporary. Then I come to the repertoire of guitar. In fact, there is hardly any repertoire for solo guitar. There's one premise by Ager or Gerritsen. But I cannot play it on this guitar because I don't have all the notes. And there are some people also improvising on the electric 31 tone guitar, but real compositions are not existing. For the ensemble, the Scala, there are quite some pieces written now. Like every year we have at least 2 new commissions, and we are existing for 5 years, so it's gradually growing, and we have a nice international repertoire. The ensemble has not only the guitar and the folk organ, but we heard it before, there's flute in it, and viola, clarinet, and we have a keyboard player, sometimes keyboard, sometimes piano, and we have percussion in it. So that's about Scala and the repertoire. At this moment I asked 2 composers to write for me a piece for this guitar and one for the electric guitar. One by Richter-Taborsky and the other one by Guus Janssen. I hope in the next edition of this festival I can show it to you. But maybe it's nice to play something contemporary on the 31 tone guitar. It's just a short prelude by Theo Louvendi. He wrote it for guitar, only guitar work. But I showed it to him and he said, it's nice to play the 31 tone guitar because there's a lot of enharmonic relations in it, and it's nice to really make a different enharmonic. So it's an octatonic enharmonic study by Theo Wett.